I got friends in LA County where the hillside shine.
Hello and welcome to the video on the area between two curves. So sometimes we are interested in the area between two curves or two graphs, and even if not, then it's always cool or kind of a pretty awesome feeling to know how to at least calculate the area between two curves. I mean, you can brag to it to your friends who maybe don't know how. Or you can have an intelligent discussion and some kind of intellectual debate on finding the area between two curves. Anyways, okay, so let's get to it. So let's say we have a graph, right, or actually two graphs, and we have some function floating up here. This is our f of x, and then we have another function, which is our g of x, okay? And we really want to find on this interval AB, for some reason we are, I'm not going to question the motivation. Well, I guess the motivation could be to understand it so you can do well in your class. But anyways, at the very least, so what we want to find is this area in between the two curves, okay, on this interval AB. All right, and and this is if our f of x is a greater function than g of x, or equal to, right? So this is our upper function, and this is our lower function. All right, so how are we going to do this? So basically, what we're going to do is actually break it up into two separate kind of problems. So here's, let's say, here's our f of x. So here that is. F of x is this, and a to b is there. So the entire area under the f of x graph looks like this. Okay? Now let's look at the g of x graph a little bit separately, right? So now we have something that looks like this. I drew in two humps there, so g of x. And then here's our a to b, right? So here's a, there's b. And now this area looks like this. So I'll draw the lines this way. Okay? So what we really want is the area in between. Okay? So if I graph them on the same one, on this last one over here, here's f of x, here's our g of x. Okay? So there's g, there's f. What we really want is this in here. Right in there, that section here. Okay? So in order to do that, we're going to take the entire area of under f of x, which is our greater function, and then subtract away the area under our g of x. Okay, and in doing so, see how here I've, let's say I have this f of x, right? So this is the entire function here, right underneath. That was the entire one. But now I'm going to subtract away the bottom, okay? So if I subtract away that bottom area down here, that leaves us with the top, whatever is the area in between, okay? So formulaically, this is what it looks like. So we have the integral from a to b of f of x dx, which is our upper one, right? So this is the greater area, minus the area under the curve of g of x dx, which is our lower function, okay? So this is basically going to equal the area. So all of this is the area between the two curves, between f of x and g of x, okay? And another way to write this, since we do have the same limits of integration and the same differential with which we're integrating with respect to, which is x, then what we can do is actually combine this into one integral from a to b of f of x minus g of x, and then dx. So we can just kind of squish it together into one integral, and this gives us our area in between the two curves, okay? And another way to write this also is that the area between two curves is equal to the integral from a to b of y, which is a function of x, y top minus y bottom, okay? And then our dx here. So y in this case is like a function of x. So y is some function of x. Y top would be f of x, so y top, and y bottom is equal to g of x in this case, okay? Alright, so here's one more. I just want to offer another interpretation if this would make maybe a little bit more sense, just a little more insight here. So here's our x and y axes, and then here's our f of x. That was a very nice curve. And here's our g of x. Okay, so, and again, here's our a and b. Alright, so in finding the area between these curves, we have derived the formula that area is equal to the integral from a to b of f of x minus g of x, and then dx. So what I want to say is that we're going to know that this gives us the height difference or length between the two curves, f and g. So if we look at it, at one point inside AB, f of x minus g of x gives us this length here, Okay, f of x minus g of x is this point, is that length there. And if we keep drawing these lines, it's basically vertical lines that we're drawing, right? The height difference between the top and the bottom, and we're integrating on a to b. So this interval, that tells us how far left we're going and how far right we are going. Okay, so that's basically it. That's what our intervals, our limits of integration tell us, are how far left and right to move. Okay, how far we're going to draw those vertical lines. Okay, so now that we know the formula, that's the easy part. We have to, when we're actually faced with a problem, we have to identify which function is the top and which function is the bottom. And oftentimes, we're actually going to have to do that without knowing what the graph looks like, which is a little bit scary, but I'll show you how to tackle that. Alright, so let's say we're trying to find the area of the region between the graphs. So I'll give you two functions of graphs. So f of x is equal to x squared minus 4x plus a 10. And then and g of x, which is given by 4x minus x squared. Okay, on the interval 1, 2, 3. Okay, so that's our a and that's our b. A equals 1 and b equals 3. And these are our two functions. So first of all, we're going to see which one is our top function and which one's our bottom function. So what we do is we try f of x minus g of x, okay? And we see whether we get a positive value or a negative value. And we can plug in a point on our interval here, okay? So f of x minus g of x, that's going to be f of x minus g of x is equal to x squared minus 4x plus 10, and then minus our 4x minus x squared. And so what we're really looking for, I'll tell you what as we get through and we're working through the problem, I'll tell you what a positive number would signify and what a negative number would signify. So as we're continuing here, we get x squared minus 4x plus 10. And when we distribute that negative, we get minus 4x plus an x squared. Okay, so that's going to turn out to be a positive 2x squared, and then minus an 8x and plus a 10. Okay, so this, if we factor out a 2, we can get 2 times x squared minus 4x and plus a 5. All right, so here, what we're going to do with this guy, this is our f of x minus g of x. What we're going to do is test a point in the interval. So we're going to test a point in our interval. Okay. And the interval includes the endpoint, so what I'm going to do is pick an easy one. It's always good to pick an easy point to make things easier for yourself. So I'm going to pick this one here. So if we try f of 1 minus g of 1, basically, that will equal 2 times 1 squared minus 4 times 1 plus 5, which is 2 times negative 3 plus 5, so that's 2 times 2, which is equal to a positive 4. Okay, so what does this positive 4 mean? I'll show you on the next slide. So when we plugged in a 1 into our f of x minus g of x, this is equal to a positive 4. And what that means is that when we took the value of our function, f at 1, in this case, so this is actually f of 1 minus g of 1, hold on, I'm trying to get a g here, g of 1, that was f of 1 minus g of 1, okay? And that turned out to be a positive 4. Let's say, for instance, we got f of 1 minus g of 1 is equal to a negative 4. So what that would signify is that our f of 1 is a lower value than our g of 1. So that means that this distance here going upward, that's a negative 4. Okay, but we didn't get this one. We got the positive version here. So that means that f of x is indeed our top function. Okay, so that means f of x is the upper function, so that's our top one. And g of x is our bottom function, the lower one. Okay. All right. So now that we've determined that, let's continue on with our problem. So we have we're trying to find the area of the region between f of x and g of x on the interval from 1 to 3. So we've deduced that f of x is our top function. So I'm going to write top here. So that's going to equal. We're just going to take our normal function that we were given, right? And here I just like to organize my information. So, and then for bottom I usually write bot, so top bot, right? So then 4x minus x squared there. Okay, so our area formula is equal to the integral from our endpoints, so 1 to 3 in this case, and then top minus bottom. So top minus bottom, and then our dx, okay? So this is going to be equal to, area is equal to the integral from 1 to 3 of top is given by the formula x squared minus 4x plus 10 minus bottom, so it's a 4x minus x squared. And then our dx comes at the end, all right? So this, we know, is equal to the following. So we have area is equal to integral from 1 to 3 of, and then we get a 2x squared, and then minus an 8x plus 10 when we simplify that. Okay, so we'll continue this on the next slide. So far we have a is equal to integral from 1 to 3 of 2x squared minus 8x plus a 10, and then dx. So we're just going to integrate like normal here. So we get 2 times x to the third, 1 over 3 comes in front, minus an 8, and then we have x squared, 1 over 2 in the front from the power rule, and then 10x. And we're going to evaluate this from 1 to 3. Okay, so the area is going to be given by 2 over 3 x to the third minus 4x squared plus a 10x, and evaluate from 1 to 3. So if we continue, we get 2 over 3, so 2 over 3 times 3 to the third minus 4 times 3 to the second plus 10 times 3. Okay, so that's when we plugged in a 3, and then we're going to subtract when we plug in a 1. So 2 over 3 times 1 to the third minus 4 times 1 squared plus 10 times a 1. Okay, so simplifying, we get area is equal to, so here we have this 3 and this 3 cancel, so we get 2 times 3 squared, so that's going to be 2 times 3 squared, so that's 2 times 9, so that'll be an 18, and then minus 4 times 9, so that'll be a 36, plus a 30, minus 2 over 3, and then minus a 4 plus a 10. Okay, so let's continue this one on the next slide. So now we have, so again, our area, I'll just write down what we had on the last line so we can follow along. So minus 36 plus 30, and then minus, in parentheses, 2 over 3, minus 4 plus a 10. Okay, so then our area is going to turn out to be, so this is a negative 18 plus 30, so that'll be a positive 12. And then minus, we have 2 over 3 plus a 6, okay? So this is going to be the same thing as saying, so this is 12 minus this 12 and minus a 6, so that'll be 6 minus 2 over 3, which is the same thing as 18 over 3 minus 2 over 3, getting our common denominators, so that would be 16 over 3, okay? So that is the area between our two curves.